Hello and welcome to physics. Today we're going to look at electric charge, which is a part of the study of electrostatics. What is electrostatics? Electrostatics is the physics that deals with interactions of static or non-moving charges. Positive charges attract negative charges and repel other positive charges, and negative charges attract positive charges and repel other negative charges. So if we look at the following picture, we can see that the negative side is attracted to the positive and the positive is repelled away. Now, in order for us to move those charges towards in the opposite direction, we have to do work, but the attraction and the repulsion on either side happens automatically. Okay, so what's the difference between static electricity and normal electricity? Okay, static electricity is non-moving charges, and normal electricity is what we call current, and the word current means to flow, so it's flowing charges inside a conductor. So if we think about it, static electricity involves charged objects that are static, means they are not moving. Static charged objects create an electric field that interacts with other charges or charged object around it. A current is a flow of electrons, so that's the opposite. Now, in summary, a static charge creates an electric field, and interestingly enough, and we'll study this a bit further, but in the future, current charges or moving charges create magnetic fields. Okay, so electrical conductors are materials through which electrons may flow freely. So if we look here at the bottom, we have electrons we've got in a metal. So the gray circles are the atoms, and they have free electrons, the outer electrons, that they have the ability to move around. In chemistry, you call them the sea of delocalized electrons. Okay. So sharing charge between two similar conductors, when a negatively charged balloon is brought close to two spheres, okay, that are touching, we see that the negative charges are repelled and the positive charges stay on the left hand side. If we separate the two, we can charge the two positively and negatively as a result of this. Okay, so there is sharing. So whenever two spheres are in contact, or any conducting sphere, the charges always distribute equally, and when two of them are next to each other, the charges can flow from the one to the other. Now, using this, and we're going to look at this in the next video, how we can charge objects. This is one way to charge an object. Okay, so there's a few experiments or a few things that you can do at home to demonstrate electrostatics. Okay, one of them is rubbing a balloon against your hair, and then you can do interesting things with the balloon. Pick up a piece of paper, stick it against the wall, play around with some Rice Krispies and things like that. Okay, you can also rubbing your balloon and putting it against your cat. It might it might be a fun exercise. I'm going to try this soon, and might make a video of this, maybe not. Okay, then you can also rub a balloon, okay, and then attract running water. You need a thin stream of water, and water is attracted by the balloon because water has what we call a polar molecule, a positive and a negative side to the atom, and therefore it is attracted to the balloon. Okay, here we see if we have an electrostatically charged object, like the hand in this case, how sand is electrostatically attracted to it. Okay, you can do the same thing here with Rice Krispies. Since the sand is so light, you can see that they are constantly moving there. Okay, here is other statically charged object, styrofoam. Okay, we can see the guys playing around with it a bit. And yeah, there's a lot of other things that you can do with static electricity and your hair. Okay, guys, now we're going to look at how we charge things electrostatically. There are three ways that we're going to charge things. The first thing is charging objects by friction. Different materials have different affinities. Now, affinities is how much they want electrons. For electrons, some hold onto their electrons tighter than others. A greater affinity for electrons is when the objects hold electrons stronger and often gain electrons by friction and become negative. Less affinity for electrons is when electrons hold electrons weaker and often lose more electrons by friction and become positive. Okay, so what we can see here, guys, is that when we rub a cloth against the PVC pipe, the cloth has a low electron affinity. It doesn't keep onto its electrons, and the pipe has a high electron affinity. So if we think about it, the cloth ends up being positively charged and the pipe ends up being negatively charged. So here's just a table to tell us a little bit more about electron affinity and which objects are most probably going to be negative. Anything at the top and anything at the bottom is more likely to be positive. So I always tell students the easiest way to remember it is that the plastic-like substance will most probably become negative, and the cloth-like or paper-like material, wool-like material, will always become positively charged, except for glass, which is a exception way at the bottom there. Okay, so if I take PVC and I rub it against silk, PVC will become negative and silk will be positive. So if you rub any of these two objects with each other, the higher it is in the table, the more likely it is to become negatively charged. Okay, so what happens is when we have an object that has less affinity and rub it against an object that has more affinity, we see that the electrons from the one move to the other. Okay, so here are two rods made of positive and negative charges, like everything is. So everything is neutral. Would these rods be attracted or repelled to each other, or would they just sit still, and why? So if we think about two neutral objects, guys, will not attract or repel each other because they are both neutral. But the moment they get a charge, they will either attract or repel each other, as seen in the beginning. Secondly, we'll look at charging by induction. You can induce a charge in a neutral object by moving a charged object close to it. For example, when you take a rubbed balloon and stick it against the wall. You didn't rub the wall, and now all of a sudden the balloon sticks to the wall. Or the cat. You never rubbed the cat, but now the balloon sticks to the cat. Okay, so induction creates a temporary and opposite charge in that other object with no contact. So without touching or rubbing the wall, it creates a temporary charge. This is considered temporary because no electrons are transferred and neutrally returns back when the close charged object is removed. Okay, so if we look at an example of this, okay, or just firstly, there's a few facts. There's no contact, it's opposite charges, and it's only temporary. Now the word induction means to force, so it's not a natural thing, it's forced, and therefore it would return automatically once that object is not close anymore. Okay, charge when charged by induction, positives produce negative charges and negative charges produce positive charges. So here's an example of charging by induction. If we look on the left hand side, we see a negatively charged rod moving towards a neutral sphere. The neutral sphere's electrons are repelled by the negatively charged pipe. You would notice the protons don't move because protons don't move at all. It is the free localized or delocalized electrons inside the atoms that move. Okay, so on the other side we'll have that would be positive induction. Negative induction on the right hand side is when the positive rod comes closer to the charged object, and then we see the electrons move towards the surface, once again creating a temporary negative charge. Okay, the third type of charging is by conduction. Conduction occurs on a neutral object when a charged object is in contact with it. So during conduction, the same charge is created in a neutral object. Electrons will transfer from a negative object to a neutral object, making it negative. Electrons will be attracted by a positive object, taking electrons from the neutral object, making it positive. Charging by conduction is considered permanent since the electrons move to a new object until that object is grounded. Okay, so here we see that we have a negative charge pipe. We've got a neutral sphere. And what happens is that the moment we touch, this is a metal sphere, so that the charges can be transferred, and as it touches the pipe, the electrons move over, creating a negatively charged object. A few facts of charging by conduction. Okay, there is firstly contact. Okay, the same charges are produced and it's permanent. So the charge, when we charge object by conduction, negative objects create negative charges and positive objects create positive charges. Okay, so now what would the difference be between conduction and induction? On the left, we see induction. We do not touch the object and it is temporarily, okay, and there's an opposite charge. By conduction, the objects touch, okay, both of the objects are neutral, but conduction, they touch and there's a transfer of charges permanently, and it produces the same charge. Okay, now induction, then conduction of a electroscope. So a gold leaf electroscope is a device that we use to see electrostatic charges. If we bring a negatively charged rod closer to it, we see that all the electrons are pushed downwards into the gold leaf. Okay, now the moment we touch it, we permanently transfer extra charges, and then the gold leaves keep on repelling each other. So in the next video you will see here he's charging, he's got an electroscope and he's repelling it. The moment he touches it, he takes off all the excess charges and then keeping or leaving the object positively charged so that the object can remain charged and the gold leaf would stay up. Okay, now grounding. What is grounding? We'd see it just now when the guy touched it. Grounding is the removal of a charge by producing a conductive path to the ground. The earth both accepts and gives electrons to neutral objects. Electrons move from negatively charged objects to the ground until the object is neutral. Electrons move from the ground to the neutrally charged object, to the neutralized positively charged objects. Okay, so here is an example. A negatively charged object is brought close to a sphere. Okay, we see this is induction, and then we remove the charges by earthing it and touching it, and that creates a positive charge when we take the rod away. The use of static electricity. First thing that we use very often is photocopiers. So how does a photocopier work? Firstly, photocopiers use static electricity. They work by, one, copying an image of the page onto a heated plate. Okay. Secondly, the light then causes the charge to leak away, leaving an electrostatic impression of the page. Thirdly, the charges left on the plate attract small drops of black powder. Fourthly, the powder is transferred from the plate onto the paper, and the paper is then charged to fix the powder. Okay. Also, inkjet plates. Okay, as droplets leave the nozzle, they become charged. They are then attracted to the positive plate and repelled from the negative plate. The voltage and the polarity, the charge size or the direction of the charge of each plate can be varied, so whether it's positive or negative. The polarity will affect whether or not the droplets go up or down, and the voltage will affect how much of the drops are deflected by. Okay, so a few dangers of static electricity, guys. We know that static electricity can easily catch fire, so especially with cars, planes, things like this. Planes, they have to earth to the ground, connect them to the ground to make sure that all excess charges are removed. Even at petrol stations, they warn you about static electricity. Here is a video of a lady whose car caught fire, and you could see that she was only touching her jersey, most probably in winter when we've got more static charges. And then, guys, there's a lot of other dangers of electric shock. Here's a video of me playing around with a thundercraft generator. A few interesting things that I played around with there. You could see that static electricity makes bulbs flash spontaneously. So there's kind of conduction there. But also, yeah, you can see when I touch it, it kind of shocks. You know that when someone touches you, when they've been charged, that they can cause electric shock, and those shocks can be dangerous in many places and in many ways. Lastly, we're going to look at electric fields. Okay, now a static charge will produce on an object creates an electric field around it. Okay, so what we see here is a charged object. We call it a point charge, and we get the direction of the field by imagining where a small positive test charge would go. It would go directly away from the positive and directly towards the negative. Okay, so if we've got two charges, a positive and a negative, we get a field of attraction. The object will move away from the positive and then be attracted by the negative. Hence, we see the curved lines. And then, if we have two positives or two negatives, they will repel each other away from the one directly, but also then away from the other. Hence, is there no attraction between them, no field. That means the objects are repelled. Okay, so how do we draw electric fields? Electric fields are drawn to represent the way a positively charged particle will move if placed in an electric field represented by a or multiple standing charges. Okay, lines are drawn to represent the field. Spacing between the lines show the field strength. Arrows are drawn to represent the direction of the fields. Arrows point away from positive and towards negative charges in the direction of a positive charge would travel in the field. Thank you very much. I hope that you understand this lesson, and if you've got any questions, please let me know.